All right, we're going to do one more thing about writing the equations of the lines. We're going to get more specific. Okay, we're going to talk about parallel lines. We're going to talk about perpendicular lines. So, Braden already said parallel lines go like this. Perpendicular lines go like this. All right. On YouTube, you wouldn't be able to see what I just did, but you get the idea. But I want to be more specific. But we'll be general at first. Let's talk about parallel lines first. All right. So if I have two lines that are parallel, so I'm going to copy and paste and put them down here like this. All right, it's good enough. Guys, please stop. Okay, we've started now. So these are parallel lines. If I told you that they were parallel lines, now what have we been talking about lately? We're talking about the equation of a line. We talked about m. What was the m in our equation of a line? The slope. So let's talk about the slopes of parallel lines. So what are the slopes? The slopes are, look at that, these two right here. Now I drew them horizontal, but they don't have to be horizontal. They could be at any kind of angle, as long as they're not facing each other. Parallel basically means two lines that don't do what? They don't intersect each other. Okay, intersect's a better word than cross. I get it, what you're saying, but intersect's a better geometry word, math word. All right, so they don't have to be like horizontal or vertical. They could be slanted like this. So it's perfectly fine. But what do you think might be true about how steep this line is compared to this? All right, they are equal. The slopes are equal. Okay, so whatever the slope is of this, I don't know, let's just say it's 2/3. Okay, it goes up, it is positive. So let's say the slope of this line was 2/3. If this line right here is parallel to it, what would the slope of this line be? It would be 2/3 as well, wouldn't it? Why? Because they are parallel. I don't think they do it in this book, but in geometry, we had a little symbol to show that they're parallel. Do you remember that? Like somewhere in there? Yeah, it could be double lines if we're comparing them to something else, but usually we just do these single little arrow things. That right there means that those two lines are parallel to each other. And again, if the lines are parallel to each other, they have the same slope. That's super important that you understand that. That's the key. Well, it's half the key anyway. There's two things we're going to talk about. That's half of it. All right, so the slopes are equal to each other. All right, let's do another set of lines. What's the other set of lines? I'll leave that right there. Perpendicular lines, good. All right, so let's draw, I'll tell you what, we'll just go horizontal and vertical just to make it a little easier. And so that's horizontal, that's vertical. So those two lines make a what kind of an angle? Oops. What kind of angle do those two lines make? A right angle. I'm just going to slant it just to show you it doesn't have to be horizontal and vertical. All right, we could tilt it like this. And these lines right here, I'm just too lazy to put all the arrows and all that stuff, all right? But they are lines. They keep on going forever. And if they make a right angle to each other, all right, which is a 90-degree angle, we say these lines are what? Perpendicular, all right? We spent a lot of time last year, or 2 years ago. Did you do any of that in Algebra 2? I don't know if you did that. I kind of doubt you did that in Algebra 2. Maybe a little bit. Yeah, I think you might did a little bit of it. Okay, but we did a lot of that kind of stuff. All right, so if they're perpendicular lines, the slopes, now let's take a look at it. Let's just talk about the sign of the slope. So this, we'll call this line L, and we'll call this line M. Is that all right? So look at line L. What is the sign of that slope? I kind of made it obvious. So from left to right, it goes up. So what is the sign? Is it a positive or a negative slope? Positive. It's positive. Okay, so this is a positive slope. What is line M? Negative. It's a negative slope because from left to right, it goes down. Shh, come on, up here. All right, so you know one's positive and one's negative. All right, so they are opposite signs. Okay, so if you have perpendicular lines, the slopes have opposite signs. One's positive, one's negative. But here's another thing that's true. I could go through and kind of give you, I'm not going to, but like a reason why, but I'm not going to do that. This right here, let's say the slope of this, let's say the slope of this was, I don't know, let's like 3/2 this time. It's positive, right? It looks a little steeper, right? You go up 3, you go over 2. Close enough. If the slope of line L is 3/2, what's the sign of this slope right here? Negative. It's going to be negative, And then it's going to be the complete opposite. See, this is a little bit steeper. This is not as steep. This is a little bit flatter. And in fact, it's the reciprocal. It's the negative reciprocal, right? So this would be what? If this is positive 3 over 2, this would be negative 2 over 3. You remember that from geometry? They're negative reciprocals of each other. That's what I'm going to write. Are, I guess different teachers, different books could explain it different ways. This is how I've always explained it, and I kind of like this. It's negative reciprocal. What's reciprocal mean?
Opposite.
Well, it means you just flip the number, okay? So 3 over 2, if you flip it, it's 2 over 3. But if one's positive, the other one's got to be negative. All right, so perpendicular lines, the slopes are negative reciprocals of each other. All right, so for instance, what if I had the slope of line 1 was 4. Here's how, now, books don't do this. I do this. I kind of like how this works, but what is the slope of, watch what I'm going to do. Put a little perpendicular symbol right there. Do you see that? So what is the slope of the line that's perpendicular to this line? Negative 1 over 4. Remember, you got to flip it, because what is 4? 4 is 4 over 1. So this is going to be negative 1 over 4. Everybody with me on that? Okay. So, I mean, some people get mixed up with that one. That's why I picked a whole number right there. But it's very easy to see if the slopes are, or if the lines are perpendicular. What do? You look at the equations. Sometimes they won't give you a picture, and you can't see that that they're perpendicular. But they'll give you an equation, right? And, well, 2 equations, one for one line, one for the other. And then you want to be able to look at them and say, oh, yeah, I see. They're parallel. How do you know they're parallel? Do you need a tissue or anything? I got towels. I got tissues up here. Right under here, I've got a tissue if you need to grab some. All right? So if they're parallel to each other, they have the same slope, right? So if you see 2 equations, and they have the same slope, look, I feel for you because I get allergies too. I take Claritin every morning because of my allergies. And the other day I had a sneezing fit. I couldn't stop, so I get it. But you don't have to make a spectacle of yourself. Okay? All right, here we go. Let's do an example. Here's the kind of stuff that you're going to be doing. All right? That's what everybody wants to know. How do I do the homework, right? That's all you care about. So let's do that. All right, here's... Oh, let me show you one more thing before I show you this. I'm going to talk about another word. We didn't really mention this in geometry, but let's see. What am I going to do? Let's do this. I'll just try to slide it up in here. Watch. Everybody look. So what if, let's use a different color. I'll just draw some random line right there, okay? So if I copied and pasted it, those 2 lines right there, what's true? If I copied and pasted, they're exactly the same, right? Except they're just off center a little bit, right? Would you agree? All right. But no matter how I move it, what's true about the slopes? They're the same. They have the same slopes. Now watch this. What if I take that line? They're 2 different lines, right? Two different lines. They have the same slope, but they are 2 different lines. In fact, let's do this. Let's make it blue. There we go. Okay, so what if I took, if I can grab the thing, there we go. All right, what if I took it and put it directly right on top of the red one? Same slope, same y-intercept, everything, same equation, right? They're 2 different lines, but they have this, but they're the same line, right? They have the same equation, I should say, even though they are 2 separate lines. Yes. So we say that those 2 lines coincide. All right, so if they have the same slope and same y-intercept or the same equation, then we say that those lines coincide. So they're going to give you 3 choices. They're going to say, are the 2 lines, what's the first choice? They could be what? The 2 lines. They give you 2 lines. They could be parallel, they could be perpendicular, or they could coincide, okay? So that's, and they say coinciding, all right, coinciding. You know what that means, right? Oops, siding. So if they coincide, that means they're right on top of each other. Cam?
You said if they have the same equation.
If they have the same exact equation, right? Now they are 2 different lines. You got a blue one, you got a red one, right? But they have the same exact equation, so they have the same slope and the same y-intercept. If that's true, then they're considered to be coinciding, all right? You got parallel, perpendicular, or coinciding. So that's what we're going to do right now. So let's write you a couple equations, and I want to see what they are, okay? Or they could be neither, right? They might not be parallel. They might not be perpendicular. They might not coincide. They may, if I can grab this, let me see if I can. Oops, now they're together. Let me just try to grab one of them. There we go. Watch. If I, like right there, are they parallel? Are they perpendicular? Are they coinciding? So what would you say? You would say they're neither. Exactly. So if they don't have the same slope, all right, then they could be perpendicular, right, if they have a negative reciprocal slope. But if they're not, then it's neither. Okay, enough of that. Let's do this. Let me give you two equations. Here's the first one. 3x minus 4y equals 12. And then 9x minus 12y equals 72. All right, so I need to determine, are those two lines, are they parallel, perpendicular, coinciding, or neither? All right, so what do? I don't just look at it the way it is written right now. Okay, I put it into the form that I like. What form do I like? Slope-intercept form. So let's do it that way. So basically, all we're going to do, what algebra are we going to do? We're going to solve for what? Y. We're going to solve for y, because we want to write it y equals mx plus b. Yes? So go ahead and try it. So here's the first step I would do. See what I did? I just moved that x over here to the other side, slid the 12 over, stuck the 3x in between, but it's got to be a minus 3x because I subtracted 3x. Can you do that in your head? Yeah, at this point in your math career, you should just be able to do that part in your head, all right? And now we divide by negative 4. So y equals what? What's this going to be? If I divide by negative 4, I'm going to divide that by negative 4. What's that? Positive what? 3/4 x. What's that? Minus 3. Okay? I subtracted 3x from both sides. I put the 12, I just moved it over to the right a little bit, and I put the x in between the equal sign and the 12. See? No?
How'd you get 9x?
I didn't. That was my second equation. They give me two equations. They give me one equation, they give me two equations. I just took the first one and I did it over here. Okay? If you wanted, you could rewrite the equation, but I just looked at it over here, translated it over here. Okay? So that's what this equation 1 is. That's equation 1. All right? Or line 1, whatever you want to call it. Let's do the same thing for 2. Let's do the math. It's going to be negative 12y equals what? What am I going to do with that 9x? Yeah, subtract it, but I'm going to put it before the 72 because I want y equals mx, right? Plus b. So I put minus 9x plus what? 72. Divide by negative 12, so I get y. Divide this by negative 12. Divide this by negative 12. Everybody good?
Yeah.
Negative over negative, 9 over 12. Can we reduce that? 3/4. So it's positive 3/4. What? Negative over negative is positive. 9 over 12 is 3/4. 3 goes into 9. 3 goes into 12. Okay. Now look. Right now, look. What's the slope of the first line? 3/4. What's the slope of the second line? 3/4. So at the very least, they're what to each other? They're parallel. They could be, though, what? Coinciding if the y-intercept's the same. All right, so we got to do a little bit more work. All right, so what's that? Minus what? 6. Yep. Now take a look. This is equation 2. Look at this one. It's not my answer. I'm not putting it in a box because that's the answer. I'm just showing you. So that's my first equation. That's my second equation. The question is, on this problem, is are they parallel, perpendicular, coinciding, or neither? Okay, what are they? They're parallel. Okay, that technically is the answer. Now, if you do this on a homework or even on a quiz, and all you do, I don't see any of this work, and the only thing you do is write down parallel. Am I going to give that to you? Probably not. Okay, probably not. I have to see why. All right, I got to see why. And if I see two equations and I see a slope here and a slope here, then I know that you did enough work to say that they're parallel to each other. So don't just take a guess. I mean, you got a 25% chance of guessing, but that's not a great chance, is it? All right, so get 100%. Make sure you find the equations and go from there. Let's do another one. And yeah, we got a little bit more to do, so let's do this one. Here we go. This is part B, still example 1. So here's your two equations. 15x plus 12y equals 36, and then 5x plus 4y. I'm going to show you a little easier way to do this particular one. This doesn't always work, all right? But in this case, I don't know. I'm looking at them. I see a 5, 15, a 4, and a 12. I'm thinking,
They all divide into.
well, not into each, but what? It's the same, isn't it? Because look, what if I divided everything by 3 on the top? I would get this same exact equation, wouldn't I? So tell me something about these two equations. They're exactly the same, so that means the two lines do what? They coincide. So this would be a coinciding one. All right. Well, yeah, you could just divide everything by 3 right here, and then go 5x plus 4y equals 12. All right, and then you could show this, and then put coinciding. Now, if you wanted to go through the whole task of solving for y, feel free, all right? So if you want to solve for y on both of those, you'll eventually, I did the math, so you eventually get y equals negative 5/4 x plus 3. Okay, that's what you would get if you solve for y. I put plus 3. Yeah. All right. You would get it for both of them. That's right. You would get it for the top one and you would get it for the bottom one. All right. And then that way you just showed that both equations are the same. But in this case, they made it kind of easy for you, right, to see the relationship between those. And you're like, oh yeah, if I divide everything by 3, I'm getting the same exact thing as this. So that made it a little bit easier. All right. Enough of that. That's not too hard, is it? All right. Here's, again, this is something that we did in geometry. I don't know why I keep saying that, because I don't expect to like automatically remember it just because I tell you we did it in geometry. But here's what we're going to do. It says write the standard. I'm jumping to example 3. I skipped example 2, okay? So we're going to go to example 3. It says write the standard form of the equation of a line. So what is that form? Standard form. It's ax plus by plus c equals 0. So that's the form I want to put it in, right? Of a line that passes through this point. So passes through 4, negative 7, and is parallel to this graph right here. 2x minus 5y plus 8 equals 0. All right. What in the world? Where do we start? Well, what are we trying to do? We're trying to find an equation of a line, correct? And what we'll probably do, well, actually, yeah, I'll show you what we're going to do. If you have two lines that are parallel to each other, what do you know is in common with both of them? They have the same slope, right? So what I'm going to do is take the equation that they give us. Forget the 4, negative 7 for right now, okay? Let's just take the equation they give us and find out what their slope is. Okay? That means the equation that I want to figure out has the same exact slope because they're what? They're parallel. Everybody hear me? All right, so I want to find the slope of this. Well, this is written in that standard form. It looks pretty, looks nice, but it's not very functional, is it? So let's change it to slope-intercept, then we can look at it and figure out what the slope is. All right? I don't even care what the y-intercept is. All I care about is what the slope is. So how are we going to do that? Well, let's move this and this, the 2x and the 8, over to the other side. I want to get y by itself. So it's negative 5y equals what? Negative 2x minus 8. Divide by negative 5. Divide this by negative 5. Again, what's the only thing I care about? Is the slope. So what's the slope? It's y equals what? 2/5 x. But what's the slope? It's just 2/5. Okay, I'm going to write that. I'm going to write m equals 2/5. We good with that? I'm just going to put it in a box. It's not my answer. I just put it there for safekeeping so I remember I'm going to use it. All right. So now here's the deal. I want to find an equation of a line that goes through this point. Right? Remember what I named that point? X what? 1 and no? Y1. All right? Because they're XYs. Everybody remember that? So look what I have. I got a point. I'm going to write this down. I got a point. I've got a slope. So, yeah. So what form are we going to use? Let's use the point slope form. I think that'd be a little easier, okay? Now you got to remember what the point slope form is. I'll write it down. You just did it on the last homework. Y1 equals m x minus x1. Okay? Everybody with me on that? So since I got a point right here and I got a slope, this is my x1, that's my y1. What do I do with that y? Just keep a y. Yeah, just keep a y. So put y minus y1. What's my y1? Negative 7. We'll make that plus in a second. Equals m. What's the m? 2/5, because I just found the slope, right? The slope of the other line was 2/5. That means the slope of the line I'm trying to figure out is also 2/5. And then times what? X minus 4. Where did I get that 4? Right here. That's the point. What form am I trying to put this in? No. Just the standard form. Okay, so I don't even have to go slope-intercept right now. I can try to go from this to the standard form. All right. So let's see. Let's do the math on this. First of all, I know that's a plus 7, correct? So what would you do first? Yeah, I would distribute the 2/5, wouldn't you? So this is going to be y plus 7 equals 2/5 x minus, what's that going to be? 8 over 5. All right, what don't you like about this? Because I don't know if I even mentioned this. I should have mentioned when we talk about this. To be in true standard form, this has to be positive and it's got to be an integer. We don't want that as a fraction, okay? These can be negatives, these can be minuses, but this one, we always want this to be a positive integer. What does that mean? No decimals, no fractions, just like a regular old number, right? An integer, all right? We should know what an integer is. All right, so what are you going to do? Let's get rid of those 5s. How do I get rid of the 5s? Yeah, multiply everything by 5, okay? So watch. Remember, whatever I do to one side, I can do the other side. I can do that anytime I ever want, okay? So I'm going to multiply that whole side by 5. Oops. Over 1. And I'm going to multiply this by 5. And then what do I have to do here, though? Just the y? So that means I'm going to put in parentheses and put a 5 right there. Yeah?
Yeah.
Okay. So now, it looks like a mess, but we're actually making it easy for us. Okay, it's a lot easier for us to do it this way. So look, those 5s cancel out. These 5s cancel out. We can distribute. What do we get? 5y plus 35 equals, this is just a 2x now because those 5s went away, minus, and this is just an 8. Now it looks a little bit better, doesn't it? Yeah, we got rid of those denominators. Things look a lot better. We want the x to be first, don't we? So let's do this. Let's take these two things, chuck it to the other side. All right? So we're gonna throw it to this side. So I got the 2x over here already. I want that first, right? Because it's ax plus by plus c. So I want that there. And then we're going to take that 5y and move it over. So we do that by subtracting a 5y. Everybody see that? We subtracted a 5y. And then let's get rid of this. Minus what? No, minus 35. And that gives us minus 43. Right? And then what's left over on the left-hand side? 0. Okay? But let's make it look a little nicer. I always like to have the x, y, and number on the left-hand side, don't you? So that's just equal to 0, and there it is. That is the standard form of an equation of a line that passes through whatever that point was, 4, -7, and is parallel to that other line they gave us, 2x minus 5y plus 8 equals 0. Okay? So these two lines, this one right here, if I was to graph that line right there, and if I was to graph that line right there, what could we say about those two lines? they would be parallel, all right? And our line will go through this point right here. So if I was to graph them, that's what you would see, that they're both parallel, and our line goes through this point for -7, okay? Well, the next one is pretty much the same, except it's perpendicular. So watch, real quick, before you go. We found the slope of their line was 2/5. What if it didn't say parallel, but said what? Perpendicular. Then what would we do to that slope? Then the slope, watch what I do. I always put like a little perpendicular sign right there. Then the slope of the perpendicular line is what? -5/2. And you would do the same exact thing as you did here, except you stick in a -5/2. It's the only thing different about perpendicular, okay? All right, so I'm only giving you part A today. So it's just 12 to 20. So it's 12 to 20. It's section 15A, and it's page 36. And it's, yeah, there you go. So that's your assignment. Wow, right in the nick of time.